Here is another question for you, and well, this is coming from thermochemistry, by the way, and we really need to dig deeper into the understanding the heat of chemistry, the start of the heat in chemistry. Now, this one says calculate the change in entropy at 25 degrees Celsius for the following reaction. Now, the fact that, now take note, the fact that this is occurring at a 25 degrees Celsius, what? This is a room temperature, right? So, given the following standard entropy values, now each reactant and each product has its own entropy value. So, how do we find the entropy? Now, to find the entropy, we just say the change in entropy, all right, will be equal to summation, okay, of what? Entropies, change in entropy for the what? For the products, minus the summation of what? Entropy, change in entropies for the what? For the reactants. That's all. And now this should always be counted by number of moles. So we are going to include number of moles here, also here number of moles. Those are important for every product and every reactant. Now this is how it's going to be. So let me just break down. We have this product. So we are saying, in this case we are saying 2 moles, right, of sulfur dioxide, okay, and its change in entropy for sulfur dioxide. You get it, right? Plus, there are still 2 moles, and the change in entropy, so the entropy, not the change, the entropy for what? For nickel oxide. Like that. Minus, how many moles now on the reactant side? We have 2 moles, and the enthalpy, so the entropy for what? For nickel sulfide, plus 3 moles, all right, and the entropy for what? For oxygen. All what we need to do is just plug in the values. We have 2 moles here, okay, times here. The entropy for sulfur dioxide has been given to be 248, plus 2 times for nickel here, it's 38. I'm leaving out the units. You can plug in them later. If you want, you can carry on with the units. There's no problem with that. Okay. Now this is minus 2 moles. Nickel sulfide, we have 53. Now look, this negative is multiplying everything, so we put the curved brackets. And this will be 3 times for oxygen is 205. Then curved brackets. This negative is multiplying everything inside. That's why I've introduced curved brackets. Now, get the calculators. So, this is giving me 496 plus 76 minus 106. Again, remember this minus is multiplying everything. Eh? That will be minus this and minus that. Oh, this is giving me 615. And after adding this, I'm getting change in entropy to be equal to negative 149 joule per watt per kelvins. Now there's something that we now why is it that the value is negative? The reason is simple. Look at the number of gaseous molecules on both sides, the reactant side and the product side. Here we have on this side we've got 5, on this side we've got 4. So it has decreased. Remember what I said? When the number of molecules decrease, what happens? The entropy also decreases. That's why it's negative. So that's the answer for this question.